Welcome all to the subject Big Data Analytics for semester 7 of Computer Science and Engineering. If you remember, in the first session we had just introduced and defined big data in various ways, as well as we introduced and defined analytics. So we'll just scroll through those two PDFs wherein we had defined big data and analytics. So we said that to understand big data, 5 V's are important, which stands for variety, volume, velocity, veracity, and value. Then we spoke about big data being large data sets, anything about 2500 petabytes. So massive data sets. Big data is HASE, heterogeneous, autonomous, complex, and evolving. Then we tried to define analytics also. And we said it's used for better decision making by business people. Then we introduced 4 types of analytics by name: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Let us continue our discussion. So this is our big data analytics subject, and this is unit 1 presently we are focusing on. That too, in today's session also, the initial big data definition and how Hadoop is going to play a role in big data handling. Let us revisit again the basics of big data and Hadoop in this session. Okay, so let us start. If you look at this image, you can see the usage statistics of social media. Say, for example, the number of internet users rose to 5.07 billion. Social media users worldwide is 4.74 billion. Social media usage, almost everybody spends minimum 2.5 hours per day. The world spends more than 10 billion hours every day using social media. So this social media, smart devices, gadgets are the source of generating and consuming such varied and huge amount of data. That's why your big data came into existence. You can see here how various social media platforms are contributing to generation of data, that to varied data, be it WhatsApp, be it phones, be it Twitter, now called as X, be it LinkedIn, be it Facebook, be it any social media platform. If you look at this, you can see that monthly active users of Facebook, though now Facebook is going down a bit, 2.91 billion, and data produces 4 petabytes, daily active users is 1.9 billion. If you look at YouTube statistics, it is in billions. There are 1.9 billion users, which is the 1/3 of the internet users. There is $2 billion being paid to users who are monetizing their contents, say content creators, say YouTube influencers. This is again some statistics, like these are the number of messages generated by WhatsApp, Instagram stories numbers, messages shared by Facebook users. If you look at the data growth, then it is going up to 149 zettabytes. It is going up to 149 zettabytes by the year 2024. So they say the big data era can also be called as a zettabyte era. Zettabyte era. Now, this much amount of data, like this flooding of data, what may be the source? The source can be stock exchange like New York Stock Exchange, which is generating 4 to 5 terabytes of data. Source can be Facebook, which is growing at 7 petabytes per month. Source can be various other sites, say for example, Internet Archives and Ancestry, which are storing petabytes of data. RFID readers, sensor networks, GPS traces, retail transaction, machine logs, all these are contributing to the growing amount of data. You have your hard disk, right? Say for example, your hard disk size is 1 terabyte. Okay. But you know the limitation of the speed of reading that, right? So the transfer speed is limited. What is the transfer speed? Say 100 MB per second. So it will take more than 2.5 hours to read all the data of your that 1 terabyte task. But let us visualize like this. Instead of one hard disk, you have 100 hard disks. So So on that 100 hard disks, your data is spread across. Your entire data is not at one place, but it is divided into those 100 drives, hard disks. Those are working in parallel. Okay. So now with big data handling capabilities, we can read that data under 2 minutes. This is possible because of multiple reasons. One of the reasons can be RAID also, redundant array of independent disks, the way they store the data on multiple hard disks, solid state drives. Okay, you also have different RAID levels, but not all of them will be providing redundancy. What RAID will be doing? RAID will be placing data on multiple disks. Okay, so the I/O operations will be overlapping in a balanced way. As you have multiple disks, there is an increase in MTBF, which stands for mean time between failures. As the data becomes redundant, the fault tolerance also increases. So big data and Hadoop go hand in hand. When you mention big data, you're by default mentioning Hadoop also. So what exactly is Hadoop? Hadoop is an open source platform. Hadoop is a scalable, reliable platform. Hadoop can be used for storage and analysis. Hadoop runs on commodity hardware and Hadoop is cheap. What is the meaning of a commodity hardware? Commodity hardware means off-the-shelf hardware. Okay. So what is the meaning of off-the-shelf hardware? Any IT component which is inexpensive, which is widely available, and which is interchangeable with other hardware of its type. So that is what is the meaning of a commodity hardware. So when I refer big data, I refer Hadoop. When I refer Hadoop, I refer MapReduce. And MapReduce, what is it? It is a batch query processor. MapReduce is a batch query processor, and it has the ability to run ad hoc queries against your whole data set. And it will be giving you the data results in reasonable time, which is transformative. Along with Hadoop, you have HBase, which is like a database. It is a scalable distributed database. HBase is based on Google's Big Table and it is written in Java. So what HBase may consist of is it may have billions of rows and millions of columns on cluster of commodity hardware. HBase also is open source, distributed, non-relational. It is modeled on Google's Big Table. HBase basically is a distributed storage system for structured data. So I'll be looking at comparing Hadoop ecosystem with other systems. Say we are habituated with traditional RDBMS, relational database management system. So how they operate? They operate using ACID transactions, atomicity, consistency, isolation, durability. What is their capability? They operate on gigabytes of data. They operate interactive and batch wise. They have the capacity of read once and write many times. So the schema is on write structure. But if you look at Hadoop MapReduce, so Hadoop MapReduce is of petabytes, capability of petabytes. It operates in batch. It has the capability of read many times and write once update. There are no ACID transactions in Hadoop MapReduce. Schema on read structure, and there is linear scale. This is the difference. Hadoop works very well with unstructured or semi-structured data, okay, as it interprets the data at processing time. So hence it is called as schema on read. This provides flexibility and avoids costly data loading phase of an RDBMS. In Hadoop, it is just a file copy. When I say relational databases, I know normalization is done, right? And with normalization, redundancy is removed, integrity is retained. But for Hadoop ecosystems, normalization actually is a hurdle, okay, as it makes reading a record a non-local operation. And one of the central assumptions that Hadoop makes is that it is possible to perform high-speed streaming reads and writes. Let us look at the brief history of Apache Hadoop. How the name Hadoop was derived? Hadoop is actually the name of a baby elephant. It's a toy actually. And Hadoop was created by Dog Cutting, who also is the creator of Apache Lucene. Okay. Hadoop's origin lies in Apache Newt, an open source web search engine. Okay. Hadoop's architecture is derived from Google's distributed file system called as GFS. Okay, let us look at some numbers here directly. In the year 2008, the Hadoop ecosystem broke a world record. Okay, what world record it broke? It became the fastest system to sort an entire terabyte of data. Okay, it ran on what? Hadoop ran on 910 node clusters. It sorted 1 terabyte in 209 seconds. Okay, so it beat the previous year's winner of 297 seconds. Then again in the same year, November, Google implemented MapReduce. It sorted 1 terabyte in 68 seconds. Okay, again there were other players like Yahoo who also sorted the same thing in 62 seconds. It means large volumes of data handling capabilities increasing day by day with multiple players and multiple technologies. This is what we wanted to convey here. Now let us look at a paper, very basic paper which my students had written 3-4 years back, wherein they tried to introduce these three topics: Hadoop, HDFS, and MapReduce. Let us just have a quick cursory look at this. Let us read the abstract here. The two keywords are big data and Hadoop. Okay. In abstract, it's being mentioned that smart devices, social media, because of them, large volumes of data is being created. So when I say big data, it means what? Huge data set. It means what? Complex mechanism for integration, analysis, and insight. Okay. When I speak about big data, I naturally will be speaking about Hadoop and MapReduce and HDFS, that is Hadoop Distributed File System. Okay. So we were speaking about the 5 V's of big data by name: volume, variety, velocity, value, and veracity. When I speak about volume, it means what? Trillions of gigabytes of data being generated and the challenge of handling that. When I speak about data variety, what it indicates? Data may be structured data like tabular data. Data may be semi-structured data like XML or CSV data. Data may be unstructured like audio files, log files, image files. The third V, that is velocity. Velocity indicates per minute count. Say for example, Facebook count. In 1 minute, Facebook 695,000 tweets, 1 lakh. Is it 1 lakh? Yes, it is 1 lakh. Messages, 11 and these many zeros. Google searches, 696445. Emails, this much. So coming to the last V, that is value. Value indicate post analysis the content generated. Post analysis the content generated of the data. The last V is again veracity. What veracity indicates? Missing, uncertain and inconsistent data. Okay. So coming to Hadoop, we said that it's a framework which is used to handle big data. It will be used for storage. It will be used for processing of large data sets. The mechanism is parallel and in a distributed fashion. What are the core components of Hadoop? HDFS, which stands for Hadoop Distributed File System, and MapReduce. What HDFS will be basically doing? Storing and managing data set on commodity clusters. What MapReduce will be doing? It is a processing component of the Hadoop. It is a processing component of the Hadoop. So just scanning through few of the contents. Let us look at the Hadoop architecture. Let us look at few of the keywords mentioned in Hadoop architecture topic. It is open source framework. It is used for handling big data. It facilitates distributed storage of large data. And it processes that large data using MapReduce paradigm. Hardware failures it can handle automatically. Many applications like Twitter and Facebook and Google and Yahoo and YouTube and Amazon, they use Hadoops. So what Hadoop does is it will be dividing its file into set of blocks, which is of size 64 megabytes or 120 megabytes. These blocks are circulated across multiple nodes. Hadoop will be applying MapReduce for processing these multiple nodes. Your nodes also are either name node or data node or secondary node. What the name node will be doing is it will be sending the heartbeat. What the data node will be doing is it will be containing the actual file blocks, while the secondary name node contains the metadata. What it does is it combines edit log with fimage file. With this, what happens is name node becomes more fault tolerant. Okay, so let us look at the diagram here. You can see the Hadoop architecture consists of name nodes, which is having metadata. Then there are racks. On the racks, there are data nodes. There is replication. So on the node, there are blocks of data. This basically is your Hadoop architecture. And this is the most famous example whenever MapReduce implementation is explained, called as word count process. So this is what we try to discuss in the second session. Thank you.